Hey everyone, welcome to another session of Ceerazzledazzle Physics. In today's video, guys, I'm going to be talking about proving direct proportionality and inverse proportionality. So this question has come up a couple of times and loads of kids don't understand how to do it. So in this video, I'll walk you through how to do it step by step. Okay, so over here, let's say we're given the following graph. So look, on the y-axis I've got intensity and on the x-axis I've got light. Yes, and we've got a straight line directly proportional going through the origin 0, 0. The question is the following: prove that intensity is directly proportional to light. 3 marks. Right, so loads of kids just simply think that, oh, I'm just going to say that yes, as the light goes up, the intensity goes up, but you've got to be able to explain it with a bit of maths here. So what the examiners are looking for is the following. So first of all, before we get started, let's just talk about directly proportional, that phrase. So in maths, it's easier for us to understand that if I have a graph of y and x, we know that y is directly proportional to x over here, so therefore we can say y is proportional to x, okay? And therefore we can then say that y is therefore equal to a constant times by x. That constant will be the same for all of the x and y values. So if I was to take this value of y here and x and worked out the constant, it would be the same as if I was to take the value of y over here and x over here and work out that constant, so the constant would remain the same. Well, now we can apply the same principle to what we've got at the top. So if we take these different values and we work out the constant, surely the constant will be the same the whole time. And that's the whole point. We're going to work out the constant for all of these different values. So let's just put down intensity. First of all, we know it's directly proportional to the light, okay? Therefore, we can say that the intensity is equal to a constant, K, times by L. Yeah, easy stuff, just like before over here. Then rearranging this, we can then say I divided by L is equal to K. So I'm going to work out the constant using this formula for all these values. So for this point here, and this point here. So let's do that. So let's check if the constant is the same everywhere. Okay, so now let's work out the value of K for all these different points. So for the first one, we've got the intensity being 5 and the light being at 10. So 5 divided by 10, it's 0.5, okay, for this pair of results. Okay, so K is 0.5, this pair of result, because we're dividing the intensity by the light. Then over here we've got 10 divided by 20. So this is 10 divided by 20, which is also 0.5. Okay, see, as you can see, the constant is the same. We do it one more time over here. So look, we can do 15 divided by the 30, which is also 0.5. And as you can see, the constant K is the same for all of them. There, there, and there. And therefore we can say that yes, this is directly proportional. The reason why is because K is the same always. Yes, so we can then make our final statement that yes, it is directly proportional as the constant is the same. Yes, as the constant is the same. Easy stuff over here. So there we go, this is how you do it. So once again, you find the value of the constant at 3 different points, yes, using all the pairs of values, and then you just check it's the same each time. Okay, so this is for if it's directly proportional. What happens if it's going to be inversely proportional? What happens then? Okay, so let's look at this question. Is acceleration inversely proportional to the mass? 3 marks. Well, look, we can see that as the mass increases, the acceleration is dropping down. Once again, make sure you identify what inverse proportionality is. So if I was to have a graph of y against x over here and it's going down, we know that y is inversely proportional to x. Y is inversely proportional to x over here. Yes, hopefully you recognize that as x goes up, this number gets bigger, y will go down because the one's being divided by a larger and larger number. And therefore we can then say that y is equal to k over x. Yes, a constant. That's going to be a constant value. So then once again, if I find the constant for different points, so I can find it for this pair of values, this pair of values, and this pair of values, surely the constant will be the same. Okay, so now in relation to this, we can say that acceleration is, number 1, inversely proportional to the mass. And therefore, the acceleration is equal to a constant, k, divided by m. Now let's find the constant. So if I take the values of the acceleration and times it by the mass, will it be the same? Yes, will it be the same? So let's do the first one. So we've got 100 times by 2, yes, which is going to be 200. Okay, so the constant for this one is 200. Let's do the next one. I've got 50 times by 4, I've also got 200, okay? Next one, I've got 25 times by 8, 25 times by the 8, which is also 200. There we go. So all of them are going to be 200. So obviously the constant is the same for all of them. So look, the constant here, the constant there, and the constant there is all the same. So therefore, yes, we now know that we can say that yes, it is. So our final answer is going to be yes, as the constant is the same for different pairs of values. Yeah, so the constant is the same for different pairs of values. And that's it for another session of Ceerazzledazzle Physics. If you're looking for more GCSE Physics and A-level Physics content, why not check out my YouTube channel, which I've got tons and tons of videos to help you with your studies. Ciao, ciao, and goodbye.